and I hope that you are doing great. Firstly, I would like to thank our professor to give us this presentation, and also I thank my classmates and I encourage you to engage to attend our presentation, and also I thank my colleagues. They are presenting with me together, and so I hope you are focused in the first part, the first start. So since everyone is here, we're gonna start our presentation. My presentation title is function limit or the limit of function. So in function limit we have I have 3 or 4 points. I'm going to explain it. Number one is definition of function limit. So when if I ask you what is the definition function, what is the function? The definition of function, the limit of function is the value that a function appreciates when its independent variable appreciates a certain value. Intuitively, we can think of the limit of a function as the target value that a function aims to achieve as its independent variable gets closer to a certain point. So this is the definition of a function or limit of function. So you can go. The second point is limitation. The limit of function is denoted as follows. LIM is the abbreviation of limit. Limit function or limit of fx equal L, and x appreciates A. So I hope that you are focused here. A is the value or is appreciate is the value of or A here is the value approximated by x. Please, this is the rule. You can focus here because in the middle of our presentation we have many example we're gonna do. So mean the limit of function of x as x appreciates A is L. If x the function we are looking at, x is independent variable, and A the value of approximated by x, and L the limit value of the function. So here we have the terms. The terms, a function if has a limit for x rows to C, and if and only if is left limit and right limit. Left limit and right limit is existing. So here there's a difference also. Existed and doesn't exist. When the limit function it will be existed, and when the limit function it will be doesn't exist. X appreciates C equal L. So limit of x fx and equal L, and x appreciates minus A here is approximated by x here fx. So we have the L equal N. So here we have the graph of left hand. This is the x and this fx. So here we have the example. You can do second. Yes. This is the example. This is the example of left hand and right hand. In the left hand, we have fx and x is squared, and x appreciates 2. This is our example. Sorry, here. So here we have 1 and 2. And here 0. This 2. So how do we give the value of x here or x? So here we draw the graph, because we draw the graph here. Why I draw the graph here? Because the fx is square, and every number is square or fx is square, the graph it will be over there.